In the living room, consoles like the Nintendo Switch 2, the Xbox Series, the PlayStation 5, they all have an unfair advantage over Valve's Steam Machine. In fact, all of these systems have one thing that the Steam Machine can't have, or at least it can't have it right now, and that's official HDMI 2.1 support. For Linux-based systems like the Steam Machine, that is a different story. Linux is technically not allowed to use the full HDMI 2.1 specification. And I think it's really important to point out that this is not a hardware limitation, it's a bureaucracy limitation or a policy limitation. But Valve and AMD have been working together in order to find a way around the rules, and they found a way to fix the unfixable. This video is sponsored by boot.dev. YouTube is not my main gig. I teach high school, but for a while there, I thought about trying to make apps instead of making videos. I even got far enough into it to actually make a working calculator app. And I have to tell you, it's pretty fun, but learning programming languages can be daunting. That's where boot.dev comes in. Because they have tiny, fun, super quick lessons that teach you how to be a developer, how to think like a developer. When you use boot.dev, you learn to code by building real projects. You'll get an assignment on the left side of the screen, and on the right side, you write your code. Down at the bottom is your console where it shows you the results of your code, and if they match the assignment, then you hit submit, fireworks rain down, and you get to move on to the next lesson. As you learn, you'll earn XP, levels, achievements. The entire course is like a video game, but instead of earning a high score, or I guess in addition to having a high score, you're also gaining a valuable skill, and more importantly, it's really fun. I've been trying it out, and honest to God, I kind of got sucked in and lost track of time. If you're not sure about it, all of the content on boot.dev is free to watch, but if you have a membership, you'll get access to interactive features like hands-on coding, progress tracking, and those game mechanics that I was talking about before. So if you want to try out something new, expand your skill set, and have fun at the same time, go over to boot.dev or click the link in the description down below and use my code NerdNest to get 25% off your entire first year on the annual plan. Before we get into the nitty-gritty of what Valve and AMD are up to here, I want to explain exactly what HDMI 2.1 is, what using it would get you, and why Valve isn't allowed to use it on the Steam Machine. It's pretty complicated and there's a lot to it, but the short version is that HDMI 2.1 allows for higher resolutions and frame rates because the standard supports a wider bandwidth. HDMI 2.0, which is available to Valve, supports up to 18 gigabytes per second, while HDMI 2.1, the one that Valve can't use, supports a whopping 48 gigabits per second. That bandwidth alone allows you to get up to 4K resolution and 120 frames per second with HDR on and full 10-bit color. So you have these four things that are enabled by that 48 gigabits per second bandwidth. However, because Valve has to use HDMI 2.0, which has less than half the bandwidth, you have to pick and choose. Let's say that you care the most about resolution. You want all of the pixels, so you set your resolution to 4K or 3840 by 2160. If you do that, then you're going to have to turn off either 120 frames per second, HDR, or 10-bit color support. If you turn off one of those, then you will be able to use the other three. Or maybe you think that frame rate is more important than anything else. Well, you can have up to 120 frames per second, but not at 4K 10-bit color with HDR on. So you have to pick something, one of those other three things, and turn it off so that you can fit all of the data into the limited bandwidth. The Steam Machine that I built, because I was tired of waiting for Valve to ship theirs, ran into this exact problem. I didn't know what it was at the time, and I explained what happened with me in a link in the description down below, so you can see how I go through the whole process. I couldn't do anything higher than 1080p 60 frames per second if I had HDR on, but when I turned HDR off, I could get 4K 120. I decided that I guess that the trade-off was worth it, and I've lived without HDR ever since. Essentially, you have these four things, and you can pick any three of them. For me, I turned off HDR, and I'm fine with it. But guess what? If I had the exact same computer, the same hardware, running Windows instead of Linux, mine has Bazite on it, I would be able to support all four. So what's the problem? The problem is the HDMI forum, which is the group that controls the HDMI specification. They have specifically blocked all open source implementation of HDMI 2.1. Essentially, their rule is that there's a special code that unlocks HDMI 2.1 features. Think of it like DRM. And it's against the rule to publish that code in open source software because the HDMI forum wants to control it. Even Valve can't get full access to HDMI 2.1 legally on Linux. They even had to install Windows on the upcoming Steam machine in order to get full HDMI 2.1 specification validated on that specific hardware. This is going to seem unrelated, but stick with me for a minute. I think you're going to see where I'm going. Let's rewind all the way back to the 80s. Tengen wanted to put out more games on the Nintendo Entertainment System. Nintendo had limitations in place as to the number of games that any company could release for the NES in a year. They were able to enforce this because they had a proprietary chip called the 10NES chip. Essentially, the NES was locked, and the 10NES chip could unlock it, and only Nintendo had that chip available to them. This meant that Nintendo could limit the number of games that shipped on the system, something that they were doing for two reasons. The public-facing reason, the one that they said, is the video game crash was caused in part by shovelware and slop, shipping for home consoles. And that's true. Nintendo used the 10NES system and the Nintendo seal of quality to control what games were going to be released on that system. The other reason that Nintendo did this, and I think that this was a bigger part of it, was because it meant that Nintendo could sell the cartridges to the publishers, thereby getting some profit from every single third-party game shipped on the Nintendo Entertainment System. Tengen, which was officially owned by Atari, tried to do it the legal way by reverse engineering the 10NES chip, but they couldn't figure it out. So instead, they had their lawyers call up the US Copyright Office. They told them that they were in a legal battle with Nintendo, and they needed the code for the 10NES chip as evidence in their legal fight. And I cannot believe that it worked, because the Copyright Office just handed that information over. This allowed Tengen to make whatever games that they wanted without buying cartridges from Nintendo, and they even put out a version of Tetris on the NES. I bring all this up because this feels like a historical parallel between what Valve and AMD and the HDMI forum are doing. Valve and AMD are trying to do things the legal way, reverse engineering, but the HDMI forum keeps shutting them down. Even if they do reverse engineer the code for HDMI 2.1, I doubt that Valve would just throw it in open source because they'd probably get sued just like Tengen did, and Tengen lost to Nintendo. Valve would probably lose against the HDMI forum, even if you and I think it's ridiculous. During the announcement for the Steam machine, Valve specifically said that it would be able to run the entire Steam library at 4K 60 with upscaling. But, some lower power games would be able to hit 120 Hz easily, even without upscaling, which would seem like it's breaking the rules around HDMI 2.1. So how is Valve accomplishing this? From what I understand, they're doing two things there. The first is a technique called chroma sub-sampling. They split the video into two channels, luminance and chrominance. Luminance tells the system how bright each pixel should be, and chrominance tells the system what color each pixel should be. Most of the data is actually contained within the luminance, also called the luma channel. The chrominance or chroma channel can be reduced using chroma sub-sampling, basically reducing the number of colors that you're using, and it shouldn't be too noticeable. This means that Valve can send the information that they need through the limited pipeline of 18 gigabits per second. I do this all of the time when I make my videos. In fact, right now I am shooting this video in what's called log. This is what log looks like. It's very desaturated and flat looking, essentially reducing the chroma channel to make more room for the luma channel. This means that I have a wider dynamic range between the darkest parts of the scene and the brightest parts of the scene. Then, after I shoot, I manually add the chroma channel back into my footage so it looks like things actually do in the real world. Valve is doing essentially the same thing. I mean, I'm simplifying a whole bunch here, but they're reducing chroma to make more room for luma. It isn't without its issues though. For example, the text in very text-heavy games could have a slightly blurrier look to it. Another issue is when using HDMI 2.0 is variable refresh rate. For those of you that don't know what VRR is, or variable refresh rate, it allows your display or monitor to match the frame rate that your game is running at, and then set the refresh rate of the display to match that frame rate. This makes the gameplay look smoother and reduces screen tearing. VRR is not supported by HDMI 2.0, however. Valve is working closely with AMD, so it does work with FreeSync. The issue is that not all TVs are going to support FreeSync. Luckily for me, my TV that's over here behind me actually does support FreeSync, so I'm going to be all set. But for anybody that doesn't, that's certainly going to be something that you want to keep in mind before you either buy a Steam machine or you buy a TV. Of course, the Steam machine also comes with DisplayPort 1.4, which actually has more bandwidth than HDMI 2.1. The issue is that this is supposed to be a living room device, and most TVs don't have DisplayPorts. You can get a dongle, but when I tried that, I had horrible sound issues. It could have just been a bad dongle, though. I have no idea. But I figured out that just turning off HDR solved the problem for me, so I didn't pursue it any further. If you're hooking up your Steam machine to a computer monitor, this is not going to be an issue for you at all, as you could just skip HDMI altogether and just use the DisplayPort. But Valve is pushing this more as a living room system. And honestly, I think that the average user probably wouldn't notice anything, but for hardcore people that pay really close attention to stuff like this, I do think it is an important clarification about what exactly we will be getting with the Steam machine. From the NerdNest, I'm Bill. Thanks for watching, and stay rad.